All right, so it looks kind of like this. So you fire the gun up in the air. So here's the bullet. So what's going to happen is this bullet is going to go up, and then it's going to come back down. Okay, now it's in the downward direction. It was in the upward direction, now it's in the downward direction. So that's what we're looking at. Believe it or not, conceptually, you kind of know the answer, or at least you should know the answer. Whatever this initial speed is, all right, so whatever this initial speed is in the upward direction, believe it or not, it's going to be the same speed in the downward direction. So speeds will be the same. Okay, so conceptually, you kind of know the answer at that point. So you know the answer. So the initial speed here, this speed is the initial speed. It's called the muzzle velocity. That's the exit speed of the bullet in the upward direction. All right, so this is going to be 1792 miles per hour. Okay, who's got the I don't have a calculator, so I have to rely on you for this one. Okay, what is this in terms of meters per second, guys? So give me the speed in terms of meters per second.
It should be 800 meters per second.
All right, give yourself 5 points. I thought so. So this is going to be 800 meters per second. Okay, another thing that we know is gravity is the only force acting. Once it's airborne, so we got gravity. So this is roughly 10 meters per second squared. Okay, cool. And conceptually, you know that whatever this is, it's going to be the same here. We discussed that before. So, well, which means that up 800 meters per second, down should be 800 meters per second. So the question is, how do you prove this mathematically? All right, and then which formula to use? Okay, so you got 3 formulas. You got 1, you got 2, and you got 3. And which one are we going to use? Okay, guys, there are various ways you can do that. Once again, this is not just the one single approach. There are multiple approaches. What I'm going to do is I'm going to take the lazy way out, okay, because that's what I like doing right now. The easiest and the laziest way to do this problem is to use this one, because I know the final height of this motion. Final height of this motion is, the final height of this motion is going to land, it's just this thing is going to go up, just like that. And then it's going to come back down, just like that. So this thing, the final height is going to be right here. It's going to be 0. Final height is going to be 0. And that's it. All right, so that's the formula that I'm going to use. Square of the final speed equals to the square of the initial speed. 2 times g times the height. I know that the final height is going to be 0. Ooh, this term is going to drop. And then what do you have? Square of the initial speed equals to the square of the final speed. Get rid of the squares. That's it. Oh, are we done? Yeah, it doesn't matter. This is plus or minus. It doesn't matter because that term is simply going to drop out. All right, so the squares will cancel, which means that the final speed on the y direction is going to equal to the initial speed on the y direction, which we knew from here. We just had that discussion. So the final speed is the same as the initial speed, which is the same as 800 meters per second, which is the same as 17,092 miles per hour. No, 1,792 miles per hour. Okay, so is that making sense? It was clever. That's how it is done. Extra credit doesn't mean it's, I mean, it requires a little bit of thinking, but that's the extent of it. This one mathematically was not that complicated. It required some thinking. All right, that's one way of doing it. There's a second way of doing it. The second approach, I'm not going to show you. You could have used this one as well. But for you to be able to use that one, you needed to figure out the time using the first one. Okay, you can figure out the time from here and then go into the green zone. All right, so that would have been a lot more complicated.